All right, hello, year 9. Okay, so I'm going to go through antibiotics with you. You did a little bit of work on it on Friday, okay? So we need to understand the difference between antibiotics and painkillers. So, why is it not working? This was the challenge question, so you've got a set of data here, okay? The green is the cases of measles and the purple is the people who took or had the vaccine. The first question asks about what happens to measles after 1968. Now you've got on this box here, it shows you where 1968 is, where the measles vaccine is introduced. It's a bit weird because I must admit it doesn't line up completely with where you'd expect 1968 to be, but it's quite obvious that once the vaccine is introduced, the cases of measles drop. There's lots of fluctuation before then, but after 1968 there is a real drop in cases. Okay, so a good answer would be that in the blue box for you to read. Now it also asks about the MMR vaccine. The MMR vaccine was introduced in 1988. It stands for measles, mumps and rubella. Okay, so that was introduced here in 1988, and from then on cases have dropped, okay, even more. So now down to 2004, you've got virtually no cases of measles at all. Now some people were quite concerned about the MMR vaccine. It was quite controversial and people stopped letting their children have it, which actually led to an increase again of measles recently, okay? But it just shows on the graph the data there, getting rid of diseases. You've got a vaccine, you've got a drop, the second vaccine then causes virtually measles to be wiped out. Okay, so in terms of the difference between antibiotics and painkillers, antibiotics are produced by other microorganisms and they will kill or prevent the growth of bacteria and funguses. They don't work on viruses. So there's lots of different types of antibiotics, lots of different types of bacterial diseases, but they will not work on viruses. If you take an antibiotic for a cold or flu, it's completely pointless. It won't do anything at all. Painkillers are designed to do exactly that. They kill pain, so they prevent pain messages getting to your brain. So whatever part of your body is that's hurting, so say you've hurt your knee, for example, a painkiller will stop the pain getting from your knee to your brain, so you won't be able to feel the pain. It doesn't cure it, okay? So you've got a bit of a comparison here. So antibiotics will cure bacterial diseases by killing them. Different bacteria are killed by different antibiotics, which is why you're not always given the same type of antibiotic. Painkillers are used to treat the symptoms, which most of you got in your answer, but they don't kill the pathogens. Now, quite often, if you're ill, you will be given both of these medications. So you'll be given a painkiller to treat the symptom to begin with and make you feel a little bit better, while you are using an antibiotic in conjunction with that to actually kill the bacteria off. So quite often, these two treatments are used together. And you've got a little bit more in terms of how they work for you to read. Okay, now this is Alexander Fleming. Okay, he was a researcher. He was involved in lots of laboratories looking at microbiology, so looking at microorganisms. Now he was growing bacteria on an agar plate, on a petri dish, and he wasn't very tidy and he left it in the sink and went on holiday. Okay, so the bacteria was growing on the petri dish, he went away and left it. And when he got back, he found that a mould had got into the petri dish, and around that petri dish, this is an experiment they did afterwards, but the white dots here are growth of the bacteria. This is a sample of the mould, and you can see that all around there, the bacteria isn't growing. So the mould that got onto his plate, onto his agar plate, killed the bacteria growing around it. So like we've got there, around the mould there was no bacteria. Okay, so as I say, it was an accident, it was a complete fluke, but he discovered the chemical within this mould, and the first antibiotic is penicillin, which is named after the mould. Okay, so you've got a question here for you to do. So what evidence from the petri dish indicated to Alexander Fleming that the mould was killing the bacteria? Okay, so you can just pause the video and have a little go at answering that question. What was the evidence? What did he see that gave him that conclusion? Okay, and there'll be a model answer in a second when you replay the video. Okay, so that is a really good answer. He noticed that on the petri dish he'd got this mould, and around the mould there was less bacteria, which suggested to him correctly that this mould was producing something to kill the bacteria, and he named it after the mould, which was called penicillium. Okay, so the mould was called penicillium, and that's how he called the antibiotic penicillin. So anti is sort of against, biotic is these bacteria, these living things. Okay, so it kills bacteria. Now, important things that you need to remember: antibiotics only kill bacteria; they don't affect viruses. If you're given antibiotics by the doctor, you must finish the whole course of the antibiotics. So if you're giving them for a week, you take all of them, even if you start to feel better. So after a couple of days, you might feel great, but you need to finish the course, okay? Because otherwise, some of the bacteria will survive and get even stronger, and then we have problems, okay? So let me just explain to you why that is so important for you to finish the course. So any bacteria that would get into your body, some of them are going to be killed by the antibiotics, some of them are not. So you've got these yellow ones and then the green smiley ones that are going to be killed off by the antibiotic. These gruesome looking ones are going to be resistant to the antibiotic. Now at the moment, there's only a couple of them. So between the antibiotic and your immune system, your body would get rid of them. Now, if you start taking the antibiotic, some of those weaker bacteria are going to start to be killed off. Okay, so you keep taking it, and more of those bacteria are going to be killed. So you'll start to feel better. Okay, now eventually, only the resistant bacteria will be left. Now, ultimately, your body will help get rid of those. Okay, so your natural white blood cells, your lymphocytes and your phagocytes will help the antibiotic and get rid of those few resistant bacteria. Now the problem is that if you stop taking the antibiotic, they are going to go, whippy, that's great, let's reproduce. Okay, so they can then start to multiply. But this time, all of the bacteria are resistant. So you're going to get sick again. And this time, if you take the antibiotic, it will have no effect because each of these bacteria is resistant to the antibiotic. So you then need to either take much stronger antibiotics or you have to take a different type of antibiotic. So this is why we need to be really, really careful in our use of antibiotics so that we don't end up with these superbugs. Okay? One of the superbugs that was in the news reasonably recently is MRSA, and it's resistant to methicillin. Okay, now methicillin is another type of antibiotic similar to penicillin. Okay, but these bacteria are resistant to it. So this is why it can cause a problem, because if you get MRSA, it's much more difficult to treat. Okay, and you see these posters at the doctors. There was an advert on TV quite recently that was also suggesting not to take antibiotics unless you absolutely need to, because they won't cure a cold. Okay, so we need to avoid using antibiotics if we don't really need to. Now, your task, you can do this on paper. You've got 3 sort of stages. You are going to, everyone is going to do the core one. If you understand it a little bit better, you're going to add the other ideas to it afterwards. So everyone needs to describe what an antibiotic is and why it's bad if it becomes resistant. If you want to do a little bit more, then you're going to add to it and explain how they become resistant. If you want to do a cartoon strip, you can do. If you want to write a paragraph, you can do. And then you're going to suggest how we can stop this antibiotic resistance happening. So that's your first task. Your second task is to answer these questions either on an email to me, on a Word document, on paper, and send me a photograph. Okay, so those are your 2 tasks for today.